Let's talk about elastic collision. Here, the white ball collides with the stationary blue ball, and they both have the same mass. What happens? We can see here that the white ball comes to a complete stop upon collision, and the blue ball continues at the velocity the white ball had been traveling at. Now, what if neither balls were stationary and they hit each other? What happens? It turns out that the velocities of these balls switch, but it's not hard to verify by changing the frame of reference so that one of the balls is stationary. In this demonstration, the red ball starts off slow and the white ball starts off fast. After the collision, their velocities switch. Now, what if balls of different masses have a head-on collision? Intuitively, the larger mass ball has a larger impact and the smaller mass ball has a smaller impact, and that remains true in real life. When a heavier ball collides with a stationary lighter ball, the kinetic energy, some of it, is transferred to the lighter ball and makes it move faster than what the heavier ball was originally moving at. Consequently, the heavier ball slows down a bit because of the kinetic energy transfer, but it will still move in the same direction. In a different frame of reference, if the heavier ball is seen as standing still, when the lighter ball hits it, the lighter ball will bounce back and send the heavier ball moving forward slowly. Now, what if the balls don't hit each other head on? It turns out this problem is a lot less intuitive than someone might think, and it happens that they will always bounce off at a 90-degree angle. At the beginning, it will look something like this. The white ball starts moving towards the stationary yellow ball. This is the moment they hit each other. Here's a key observation to make. Notice the point of contact in the center of the yellow ball. The only possible velocity for the yellow ball to move in is the vector that goes through those 2 points. That velocity is also perpendicular to the common tangent. So you can think of how the original ball was traveling using the sum of 2 vectors. The yellow vector is parallel to the tangent, and the red vector is perpendicular to the common tangent, which is also the direction that the yellow ball will be moving at. At the moment of contact, the red vector will be transferred to the yellow ball. Now, the only velocity left for the white ball is the yellow vector, which is perpendicular to the red one. This is why they travel off at 90 degrees. Notice this argument doesn't hold when the two balls have different masses because we relied on the fact that all of the red vector is transferred to the yellow vector, which is not the case if the masses are different.